We're continuing with 2008 BC multiple choice. BC multiple choice. We did 1 through 6 yesterday, so now we're doing 7 through whatever, like 30, 40 minutes would be. Okay, number 7. I wish you guys were here giving me input. It's so strange to teach myself, but I'm glad that I can help you guys prepare better for the AP test. Okay, so y of 1 is -3. And then we have dy dx equals 2x plus y. Makes me think of separation of variables. Remember, this is a coordinate, 1, -3, xy. Okay. What is the approximation for y of 2 if Euler's method is used with step size of 0.5? Okay. So let's see. I like to make the chart. It's really just an organizational chart. Okay, so I have x, I have y. Those are the originals. So 1, -3. And then it says the step size is 0.5. So now does it say positive? It does say positive. So this would be 1.5. And then another 0.5 would be 2. And then I'm looking for this value, not the rest of the row. Okay, so let's see. So do you remember what you find after the x and the y? So the answer is m. So remember, m is dy dx. So let's figure that out. So in this case, m would be 2 times 1 plus -3. So 2 minus 3, -1. So that's my m. So my m right here would be -1. Okay, what do we do with the -1? Now, if you completely forgot how to use Euler's method, it says to use Euler's method. If you forgot how to use Euler's method, you really can just do a tangent line and then substitute in 1.5. And then do a new tangent line at 1.5, but it's not really a tangent line because that's not really a point on the graph, but it's this, the action would be the same. And then substitute in 2 after that. So that would be the plan. But if you can memorize the chart, it's definitely better. Okay, so definitely memorize the chart. Okay, so the chart after the chart was you multiply delta x times m. Okay, delta x times m. And this gives you the approximate change in y. Okay, so then I'm multiplying -0.1 times my 0.5. I'm on the non-calculator section, so I'm going to change that to 1/2. Okay, so that is -1/2. Okay, and basically what your new y would be, which is your last one, remember your new y is your old y plus your delta y. Okay, so let me highlight the two values. So that's the y value plus your delta y. Okay, so your old y plus your new y, your new change in y is what gives you your new y. So that would be -3.5. Okay, so that's my -3 plus my -1/2, which is -3.5. Okay, so that's right here. So -3.5. Okay, so that's my new y. These values will be the same. Okay, the new y is the y for the next row. Okay, then I need to find m again. So this time I want m, but I want m at my new value. So this is m at the point 1.5, -3.5, which is what, 1.5 and then -7/2. Okay, so m is 2 times x plus y. So I'm using the equation. So x is 1.5 and y is, oh, I guess I should leave it as -3/2. Maybe I should leave that as -3.5. Okay, I'm basically using this equation and substituting. Okay, so this would be 3 minus 3.5, which is -1/2. Okay, so the slope is -1/2. And then you take the slope, which is negative a half, and you multiply it by delta x. Delta x is 1/2. I'll write that in the front for my delta x. Okay, so my delta x is 1/2. That's the step size. And that would be negative 1/4. And then you're going to put the negative 1/4, and add it to the other yellow I have, which is negative 3.5. So this would be, this square right here would be negative 3.5 plus negative 1/4. So that's negative 3 3/4. Okay, negative 3 3/4. So let's see if that's one of the answer choices. Negative 3 3/4 should be answer choice D. And then let me check if that's correct. That is correct. Cool. Let's do the next one. Okay, number 8. Okay, number 8. So you guys have already tried this one. Make sure you try it before you do it. We're given a table. So I would say that's one category of questions that we should definitely practice for this 2020 exam, tables. Yeah, I wouldn't have thought of that. Okay, so we have a closed interval, values shown in the table. Use these intervals. What's the approximation of a left Riemann sum? Okay, when I do left and right Riemann sums, I like to draw a picture. Now the y value doesn't have to be to scale. Okay, but it's very helpful, and neither does the x value, but I really like to see it, especially if they were saying like up or lower or anything like that, but this is left. Okay, so we have 2 to 3. Okay, and I'm only going to put the values here that are relevant. 3 to 5, 5 to 8, 8 to 13. Okay, so the y value is 2 is at 6. Let's see, what's my highest y value? My highest y value is 9. Okay, so 6, 2 is 6. 3 is negative 2. Oh, that's interesting. Oh, we don't usually have negatives. Huh, this is kind of cool. Okay, so 3, negative 2. It's rare that you have negatives with Riemann sums. Okay, so negative 2. 5 is negative 1. Okay. 8 is 3. And 13 is 9. Okay, and we don't really know how the graph is sketched from there, but that's good enough. So it says, what's the approximation of the integral? So they want the integral to 13 f of x obtained by a left Riemann sum. Okay, so a left Riemann sum means that in the section from 2 to 3, you're going to use the left y value, which is the 2, to be the height of the rectangle in that section. So you're going to make that height 6. Okay, and the width is from 2 to 3, so that width is 1. So we'll find the area of that because integrals mean area. Okay, now the integral here from 3 to 5, the rectangle, now it says left. So who's left? So this one, the 2 was the left. So my next rectangle, I'll do it in green, will be the 3 is the left. So I'm going to use the y value at the 3, which is negative. Okay, now at this point, negative 2. You do need to, and then 2 is the width. Integrals are allowed to be negative. Okay, so it could be negative. So since it could be negative, oops, let me move that out of the way. Since it could be negative, this answer is really the signed area. Okay, integrals are signed area. So we're not using the rule that area has to be positive. That's only if they ask you for area. Okay, so if it's given you an integral, then we're looking for the signed area. So we are going to consider the green as negative. So when you multiply the area, the base times height, that is negative 4. And the red would be 6 times 1, which is 6. Okay, now from 5 to 8, I'll do this one in blue. So from 5 to 8, the left is the 5. So I'm going to use the height of negative 1 for that section. Now that section's width is 3. That's because that's from 5 to 8. And then negative 1 is the height. So the area of this one would be -3. This one's kind of cool. I like this one. Okay, and then black, I'll do the next one black. So 8 is the left endpoint, and that height is that. I didn't write it down on my chart, but I can check it. That was 3. Okay, so that was 3. So this would be 8 and 13. Okay, so 8 and 13 are my, let me move those down so we could see those better. Okay, so let me move those so they don't look like they are the heights. Okay, so here's 8. Okay, here's 8. And then here's 13. Okay, so the height is, I'll do this in black as well, but the height is 3. That's from this value over here. Okay. And then the width is from 8 to 13, so that would be 5. And if you're not seeing how I find the widths, I'm basically just subtracting. Okay, so this is the width. Okay, and then the area of this one would be 15. Okay, now you definitely don't have to draw the picture. So the other choice is, what I do sometimes if I don't want a picture, is I think 2 to 3, 3 to 5, 5 to 8, 8 to 13. Okay, so this is just another way to kind of phrase it, is I basically want the area to be base times height. Okay, Riemann sums are base times height. Okay, so the width of this one is 1, or you can call it width times height. Sometimes that's helpful. 1 times f of, and then plus the width is 2, f of, plus the width is 3, f of, and this width is 5, and then f of. So the f ofs are the heights. Okay, so these are each individual height. Now, which individual heights do I need? We were saying left endpoints. So left would be the 2. Left would be the 3. Left, this is the non-graphical version. Left would be the 5. And left would be the 8. So those are the values that you're going to put in here. Okay. 5 and 8. And then you find out those values from the graph. So 1 times, or from the table, because you didn't draw a graph. So we're assuming that you didn't draw a graph. Now, if you didn't draw a graph, you would have the height at 2, or the f of 2, which it says in the table is 6. Then 2 times f of 3 in the table, that says it's -2. Plus 3 in the table, that says it's -1. And that in the table is a 5, f of 8. And notice that we get the same things. This is my red area. This is my green area. This is my blue area. And then this is my black area. Okay, and then you just work those out. Okay, so this would be 6 minus 4 minus 3 plus 15. You do consider the -4 and the -3 as negatives because they're because it's integral, and integral means you do the signed area. So these 3 are -1 plus 15, which is 14. Now this is an approximate area, or the approximate integral. Okay, and then that answer is B. Let's see, does Mr. Calculus agree? Mr. Calculus agrees. Cool. Okay, I'm looking at Mr. Calculus solutions only because the other solutions I found are intermixed with AB, because some of the problems are AB and BC, but that's really more difficult because all the ABs are in order and then the BCs are random. So anyway, so I'm looking at Mr. Calculus because I know him, and he's very clear with his explanations, his written explanations usually, but also he's very meticulous, so he's going to make sure that he has the right answers. Let me remind you of some things while we're here, because we're trying to review lots of things. Let me remind you of some things that are nearby. Okay, so this is a what if. Okay, so what if. Okay, so what if it said right endpoints? Okay, so if it said right endpoints, 2 to 3, I'm going to use 3. 3 to 5, I'm going to use 5. 5 to 8, I'm going to use 8. And 8 to 13, I'm going to use 13. Same idea. I multiply the width times f of 3 plus the width times f of 5. But these widths would be different. That width would be 2. That width would be 1. Same thing. Sometimes you have midpoints. Okay, so midpoint. So instead of right endpoints, it's midpoints. And then what you would do is for 2 to 3, you would use the f of 2.5. You still say the width is 1. And then from 3 to 5, you would still say the width is 2, because from 3 to 5 is 2. And then you would do f of, but you would do f of 4 because that's halfway in the middle of the 5 and the 3. And then 5 to 8, that's 13, so that's 6.5. Okay, 6.5 is in the middle, 13 divided by 2. So that would be your width was 3, and then it would be f of 6.5. And that 1, 2, 3 is just a coincidence for this problem. 5, f of, what's halfway between 8 to 13? That's what, 21 divided by 2? So 21 divided by 2. Now, in this one, we only have certain table values, so we can't find the f of 2.5, the 4, the 6.5, and that. Okay, and then the other topic that's in this section, a little review from AB, would be trapezoids. Okay, so trapezoids, remember the formula is 1/2. The actual formula from geometry is height, and then base 1 plus base 2, that's each trapezoid. Okay, and this one won't work by the trapezoidal formula. So if you learned a long trapezoidal formula with like b minus a over 2n in the front, that's not going to work. So that only works if they're equal increments, and this one is not. I kind of do a calculus area instead. I call it width height 1 plus height 2. Okay, and I do that because our trapezoids in calculus, they look like this instead. So let me draw you the one from 5 to 8. Actually, the 5 to 8 is upside down, so let's not draw the one from 5 to 8. Let's draw the one from 8 to 13. Okay, so from 8 to 13, okay, you have this value, which is 3, and then you have this value, which is 9. Okay, so this is 9 and this is 3. And then you have the trapezoid connecting them. So if you look at this picture, this is the width, and then I'm calling this height 2, and I'm calling this height 1. So visually, I usually use this in my AB class. So 1/2, my width of this section is 5. My height 1 is 3. Well, before I do that as 3, sometimes I'll write f of 8 plus f of 13. Okay, and the 5 is the width of that trapezoid. If you draw the picture, then you can just write down the widths. But if you're not drawing the picture, the f ofs make more sense. And that would be one trapezoid. But I would have to do a trapezoid for each. So I would do 1/2, the formula for the trapezoid, the width, this is from 2 to 3, the width, and then I would do f of 2 plus f of 3. And then I do my next trapezoid, which has a new width. And then I would do f of 3, this is for 3 to 5, f of 3 plus f of 5. And then plus 1/2, the width of 5 to 8 is 3, and then f of 5 plus f of 8. And then the last one would be 1/2, the width, we just did that one, 5, and then it would be f of 8 plus f of 13. Okay, so that's how you do trapezoid. So that's a little reminder of how you do all of those. Okay, I'm going to have to make sure that I put this in the video because this is kind of a good review of all the different table ways to approximate area, or integrals. Okay, just a little review. Okay, I like to review as we go, and usually we're reviewing IB, and the IB helps us review some of these topics, but definitely not the trapezoids. That's not usually an IB topic. Graph of the piecewise linear function is shown above. Okay, linear, so that means they're all lines. Okay, is shown above. G of x equals. Now, when they set it up like this is always making me think it's maybe not true, but it makes me feel like taking the derivative and using Leibniz. So whenever they set it up, I'm always feeling like Leibniz. Now it says, which of the following values is greatest? Okay, so greatest, what does that remind you of? What word? To me, that reminds me of the word maximum. Now, are they just asking me for... Oh, they're not asking me for that. Maybe they are. I'm thinking max, but it's multiple choice. Okay, let me turn this one into a free response because free response definitely is what you're going to have more, right? You're going to have free response questions this year in 2020. So let's see. How do I want to approach it? Let me approach it the way you did first. It is a multiple choice question. So let's do multiple choice. So they're asking me for g of -3. And so let me just find g of -3. Let's see if I can find it. Now, is that the right way or the wrong way on the bounds? I believe that's the wrong way. So that's -3 to -2. So I need to flip that. Okay, so that's going to be negative in front of whatever area I find from -3 to -2. Signed area. I'll do that in a minute. Let's just see. Okay, so g of, we'll see if I have to actually find all of these. G of -2 to -2 of f of x. Now you're taking free response this year, right? So you need to make sure that it's free response only in the year 2000 or in 2020. So you're definitely going to need to be showing all your steps. Okay, the 0 is because the bounds are the same. Imagine taking an antiderivative and substituting. You're going to have the same thing for both of those. Okay, so that one is 0. C is g of 0 is, let's see, so that's -2 to 0. That is in the right order. Okay, so I'm just procrastinating at the moment. D, g of 1. It's not really procrastinating, it's more assembly line. -2 to 1, f of t dt. And E is g of 2 equals -2 to 2, f of t dt. Okay, I think I'm going to have to draw a little picture of this graph for you. Okay, that's not a good picture. So let me draw a picture so I can show what I'm looking at. Let's see. On my new tablet, I'm going to be able to do half and half. Half is this program, and then half is another program, like maybe my camera where I'm taking a picture of this. But at the moment, I do not have that set up. Okay, here we go. -2, 1 is a point, and this is 2, and then this is over at -3, 2. -3, 2. So they're saying this is a straight line. Okay, this is a straight line. That slope is slanted more. This is a straight line. This is a straight line. Okay, so let's see. So from -1 to, or now we want the maximum, right? The highest? Okay. So -2 to 0, that is, you could do it as a trapezoid or you could do it as a rectangle plus the area of a triangle. I'm going to do area triangle. So this is 1 high, 2 wide. This area is 1/2 base times height for the triangle. So that would be 1. And then this area would be 1 high and 2 wide. So area is base times height, so that's 2. So the area from -2 to 0 is 3. So that's C. So that's 3. G of 1. I do add more area. Okay, so I'm thinking this one's higher at the moment. Now, if I go all the way to 2, that's back to 3. Because the signed area, let me color these in these two colors. So look at that yellow area and look at this blue area. So the integral from 0 to 2 is 0 because they cancel each other out. So this one is saying -2, the E, to 2. So I'm thinking that would be this area, which is -2 to 0, plus the integral from 0 to 2, and the integral from 0 to 2 is 0 because of the blue and the yellow canceling out. Technically, the area would be 1 plus 1 for the yellow, and then -1 for the blue because it's below the x-axis. So that one you get 3 again. -3 to 2, this area here in the blue shading is positive. So this is a negative number, so this is definitely not the biggest. But if I needed the specific number, I would probably do a trapezoid or break it into a square plus a triangle. So that area looks like it's 1.5. 1 high, 1 wide, 1, 1, 1, a half, if you needed it. So technically it's 1.5, negative 1.5. But you wouldn't need to know that to answer this as a multiple choice question. Okay, negative 2 to 1. Negative 2 to 1 is the answer. Now, this is 3 plus, right? So this is my 3 plus my yellow, right? And my yellow I decided was, the area was 1 because it's a triangle. So this is 1/2. The width is 1. The height is 2. So that would be 4 overall. Now, this is multiple choice, so I don't need all that information. But if it was free response, I would. And then I'm going to change this into a different free response question in a minute, because the answer is just D. Okay, but it's multiple choice. Now, we're not going to have a multiple choice situation this year. So without a multiple choice situation, we need to have different possibilities. Okay, so what if they asked for G of 1 on the free response? You're going to definitely need to be able to find that out. Okay, to see the solutions, including form B. Okay, here we go. Okay, so this answer is D. And let's see. D? Yes. I would like to show you the free response version of this. Okay, so I know we only did 3 questions here, but I think this is valuable review. So let me make up a question for you. Okay, so this is what if. Okay, so what if this was a free response question? And even if this isn't in 2020 where we only have free response questions, this is definitely a typical free response question. Okay, so it's definitely possible that this is on your exam. Okay, and this could also show up in the multiple choice section as well. Okay, so, okay. Okay, so let me do a what if. Okay, so this is the same graph. Okay, so this is the same graph. There we go. And if the question said, find the maximum. Okay, and it did not give me answer choices. Okay, well, I have G. Now to find a max, I want to take the derivative. Okay, so if I want to find the max of G, then I'm going to take the derivative of G. Now, how you take the derivative of an integral, remember you use Leibniz or second fundamental theorem of calculus. You substitute in the bound times the derivative of the bound. Minus, you substitute in the bottom bound and you multiply by the derivative of the bound. So in this case, G prime of x is f of x. And I could find G double prime. I don't need it. But if I wanted G double prime, you take the derivative of f, which would be f prime. Okay, so what I'm going to do is underneath this graph, and you guys haven't seen me do this before. We didn't do this in class. But this is very important, so maybe I'll have a live video on this one too, where you guys could ask questions and I can go at a more normal speed. Okay, so in order to do a maximum of G, I need a G prime number line. So what I do, and usually I just do this in one color, but let me change colors on you so you can see better. So G prime is what I want, and then F is what I have drawn. This is an F graph, so maybe this will help with the color coding. So this is F. Now, if the number line is labeled F and the graph is labeled F, then you're looking at Y values. Okay, you're not looking for slope, even though it says G prime. That's slope of the G graph. The G graph isn't shown. So this is Y values of the F graph. So that would be above and below. That's what I call it. So anytime the graph is labeled the same, F prime, V, A, SS, FF, GG, G double prime, you always do above and below. So this is above from -3, above And then I'm pausing at -2 just to ask myself a question. Something interesting is happening there. But something interesting is happening to f with respect to slope. Okay, now usually this I cover with my hand. I cover this G prime with my hand. So let me cover it with my pen. So don't look at it, okay? Now don't cross it out, but just cover it with your finger. So put a big finger on it, okay? So put your finger on it to cover that, because you need to be focusing on F. If you look on the left side, it says slope. So it says that prime there, so you're going to get confused. Okay, so I'm still positive, positive, positive until this x value. Now that x value is not 2, that x value is 0, so that's a little tricky. And then y value, and then I'm still above until 1, and then I'm at 0, and then I'm below. And I'm below all the way until 2. Now, I don't usually put so many pluses on there, okay? And in fact, 0 probably shouldn't even be on my number line. I'm going to erase it, because at 0 was the y value 0. Nope, this whole section is above. So this is above everywhere. So this whole thing here is above. Okay, so that means I'm going up. Okay, now let me change. Hold on, let me change colors. So this was the F color. Okay, now I'm gonna do the other thing. I'm going to cover up the F and uncover the G. Okay, let me just uncover this whole thing. Call it G prime again. Now for G prime, positive means increasing. That means the G graph, not shown, is increasing from -3 to 1. And then from 1 to 2, it's decreasing. So absolute maximum and relative maximum is at x equals 1. And if they wanted to know what the maximum was, I would want G of 1. And G of 1 is -2 to 1, f of t dt. And then that would be signed area, which we did above, but the signed area from -2 to 0, I'd probably at this point, that's if I did a trapezoid, right? So that'd be, the width is 2, and then the height is 1 plus 2. You know, my math brain says be safe. You know, be safe. I see the rectangle. I see the triangle. I probably just would add those two. But it does turn out to be the same thing. And then I need to add the area of the other triangle, which its height. So this is a triangle. This is a trapezoid. 1/2, the base is 1, and the height is 2. And that would be 3 plus 1, which is 4, which is the answer we got on the other thing. Okay, but it was multiple choice, so we didn't have to do this whole process. We did not have to take the derivative. We definitely want to practice. I'm going to write this on the list. We definitely want to practice graph problems, the graph free response questions. Maybe that'll be our second week. The first week we're practicing area volume Taylor series problems, free responses, and then the next week we're going to do tables and graphs. Okay, so this graph idea is going to be very important. Okay, so sounds good. This is on the AB test and the BC test. So we definitely want to get it done. Okay, I think I'm going to stop this video for now because I do want to describe it. We're at 7 through 9, but this 9 is really pretty critical. And wasn't there another one that was critical here for tables? Yeah, number 8. Euler, I think most of you remember. But 8 and 9 are AB. But they're AB things you haven't seen in practice because we haven't been practicing that in the IB level. Anyway, very exciting. I'm going to post this one, and then I'll keep going. So I'm just going to keep teaching, but I'm going to make it into smaller videos. There we go.